completing the square is from Algebra 1. So, when you complete the square, it creates a perfect square trinomial. For example, he's been gone. He's like on some trip or something like that. That's what it is. So, if you guys remember back to Algebra 1, this is a perfect square trinomial. And to factor, you listed out the factors of the front, and you listed out all the factors of the back. That should look familiar to you. Factoring is something that you guys did. So, we then tried to figure out what this would factor into by putting x and x in front. This should look familiar to you. So, x times x is x squared, and then you would distribute this from here and here. So, we had to figure out two things that added to get to 8x. So, which things added to get to 8x? 4x and 4x. So, we put a 4 and a 4 here, because when you distribute this, 4x plus 4x is 8x. So, what sign needed to be in the middle here? Addition, because we're getting a positive 8x, right? And then when we did this, 4 times 4 is 16. So you see how that finishes up the problem. What do you notice about this piece and this piece? They're the same. That is why this is called a perfect square trinomial, because you can rewrite this as x plus 4 to the second power. So you'll notice, if you remember from yesterday, our formula, and Logan, I do see your hand. Logan's hand was up first. Just let me finish my statements here. If you notice from yesterday, this was our formula, right? Does this piece kind of look like one of the pieces in our formula? So we can complete the square to write an equation of a circle. So we are going to talk about how to do that in these next 4 problems. Logan, what's your question?
Is this like the trial and error thing?
Yes, but it's going to be pretty obvious on this one because it has to be the same thing times the same thing. So you notice that this is the same and this is the same? You need it to be the same and the same to be a perfect square trinomial. Yes?
Is that like, so the x plus 4 squared, is that just how
it factors?
You write the answer like you don't?
Yes. So that's how that would work.
Hey, so do I do the same? Do I use like the 80 for the area too?
Yes.
Okay.
Okay, so we need to complete this square by filling in the last piece. So our last piece here was 16, which was made by doing 4 times 4. Do you see that? So if we were to try to factor this so that it looks that way, we would have x and x in front. What 2 pieces would need to be here? What 2 pieces? What would it have to be? 5 and 5. Because if you distribute this, 5x plus 5x is what? And do we need our signs to be positive or negative? 2 positives. So then if we want to complete the square, we do 5 times 5, which is 25. So that is what goes in that blank to make it so that it's x plus 5 to the second power. Logan. Yeah, it has to be the same number to make a perfect square trinomial because we want to be able to write it this way so that we can get it into this equation. Yes. So that's why I'm saying it's not going to be as much guess and check as it was last year for you guys because it has to be the same thing times the same thing.
So it'll never be something that's like figure out if it's a trinomial.
You're not going to just have to factor like we did last year. That will come back to you guys right at the start of the school year next year in Algebra 2. Okay, so what numbers needs to go here to get to this negative 4? 2 and 2, and will it have to be positive or negative? 2 negative. So when we distribute that end piece, negative 2 times negative 2 is positive 4. So this becomes x minus 2 to the second power. So there's a shortcut. There is a shortcut to do this. All you have to do is take the middle term, divide it by 2, which is 3 here, and square it. 3 squared is 9. So I wanted to show you, before I showed you that shortcut, why that was the case. So if you look at this, the same number times plus the same number is dividing this by 2, right? 5 plus 5, you get that? That's where the 5 plus 5 comes from. When you do 5 times 5, isn't that the same thing as squaring it? Do you guys see that? So that's why that's the case.
So you just divide it by 2 and then square
You
it?
divide the x term by 2 and square it. So what would go in our end piece then for the last one there, Katie? Yeah. Yes, because negative 12 squared is negative 6. Anything squared is a positive, because a negative and a negative is a positive. So those are going to easily factor for us. Who can tell me what this is? What is this squared? Raise your hand and tell me what that first one is. X squared plus 6x plus 9. What is that squared? Who thinks they can figure that out? And that's what I figured, because I want you to be here in the lesson. It doesn't matter that much. What is that factor to, guys? Think about what this one was. This was x plus 5 squared. This one was x minus 2 squared. So there's a 3. But what else are you missing in here? X and it's x plus 3 squared. Good. What is this one? X minus 6 squared. Look at this number here. And look at this number here. It's just your division number. Do you guys see that? All right, so that is completing the square rundown before we get it into equations. Again, I did that super quick. You did it last year. Like I said, I might be going fast. Just let me know. I literally have been teaching this for the past week in Algebra 1, so I'm just going to assume you know things when I forgot that this isn't Algebra 1 anymore. So just let me know. Go ahead and get that written down. I'll have it on the classroom, don't worry. So how do you complete the square when it's an actual equation? You're going to bring the constant to the other side of the equation. So anything that does not have a variable is a constant. Reminder, your test is on Friday. You have a green help sheet. Can you use both sides? Mm-hmm. Yes, you may. It must be handwritten. It would be a very, very wise decision to write everything that you have learned this unit on that green help sheet, because you can use it on your test on Friday. So formulas and everything, maybe some examples if you're not very good at something. You all are in different places, and some of you are better at some things than others, okay? So just know where you're at.
Are you going to write anything on
I will tomorrow, well, Thursday for you guys in class. I will probably go over like some of the stuff to put on the green sheet and a few problems. Yeah. All right, so from there you're going to complete the square, making sure that what you added to the right side of the equation gets added to the left side. So this is always the analogy that I use. So if you've ever been to a park, you've been on like a teeter-totter or a seesaw, however you call it, right? Do you know what I'm talking about? So if you guys are the same weight, you're just going to kind of float there in the air, right, together. But if your little brother gets on with you, you're going to go down, right? So for the weight to be even, somebody of the same size needs to be on the other side, right? So this is basically saying if you add 4 to one side, you have to add 4 to the other side to keep it balanced. Does that make sense? All right. So let's try this. What is our constant in this problem here? So we're moving 9 over by subtracting it. So I have x squared plus 4x, and then I'm going to put a blank here because I need to complete the square. This is kind of how it looked on the other page. Equals 7 and then a blank. Why did I put a blank on both sides? We have to make it even. So that's kind of a reminder that what you add to one side, you need to add to the other. Does that make sense? Okay, so what goes in our blank on this side here? What goes in the blank here? What did you say? Yeah, because 4 divided by 2 is 2, and 2 squared is 4. So whatever we add to one side needs to be added to the other. So we then are going to be able to factor this into something squared equals 11. So what goes in that parenthesis, Harmony? X plus 2 squared equals 11. And that is completing the square. So that is what it's like if there is one variable in the problem. The issue is, if you remember our circle equation from yesterday, how many squares are there? There's 3 technically, but 2 on one side, right? This kind of piece happens twice, right? So we're going to skip the next one and we're going to go on to the next slide and start actually creating circles here. So let's complete the square and write the equation of a circle. As a reminder, I've been writing this a lot. The equation of a circle is as follows. So we need it to look like that. So the first step is to move the constant. Are there any constants in this one? Yes.
I had a question on the last one.
Yeah, I'm going to go back then. What's up?
How'd you get the equals 7?
I subtracted 9 from both sides, so 16 minus 9 is 7, as long as I did the math right, which is always possible that I've done it wrong. So, does that make sense now?
Yeah.
Okay. So, you'll notice, are there any constants, anything without variables here? No. But do you guys notice you have two variables? You have x's and y's? So you're going to have to complete the square twice. So we're going to put two blanks here. We have x squared plus 10x blank to complete the x's because that's going to create this part of our circle equation. And plus y squared minus 14y and then a blank equals 7. How many blanks are we going to have there on the other side? 2, because we have to add whatever we add to the other side. So we're going to need 2 blanks on the other side. So you'll notice this first part is going to create the x minus h part. And the second part here is going to create the y minus k part. So Greg, what completes the square for the x's? What goes in the blank next to 10x?
What goes in the...
In this first blank here next to 10x.
10, right?
No, because we're trying to get it so that when it factors into the same thing times the same thing. So what do we do with the 10? We take it and we divide it by
2.
which is,
5.
and then we,
So it'd be 25.
so if we add 25 here, we have to add 25 to one of our blanks on the other side. Lindsay, what goes into my blank next to negative 14y? So it would be positive 49. Half of negative 14 is negative 7. Negative 7 squared is 49. So whatever we add to one side needs to be added to the other. So we are going to then factor both of our pieces here. And it will be equal to 81. When you add those numbers together. So what goes in my first parenthesis there? What goes in my first parenthesis, Hunter? So it's x plus 5 squared. We have x times x, right? 5 plus 5 is 10. 5 times 5 is 25. So it makes sense that it's x plus 5. Okay. Ian, what goes in my second blank?
Your second blank, would it be x, right, no, y minus 7, right?
And you changed everything perfectly. It's okay to be wrong, but he kind of processed through it. First he said x. Why did you change to y?
Because I saw there was already x up there.
Right.
Plus it's y.
Yeah, you need to do y times y to get y squared, right? Not x times x. So that was a good change. And then originally you said plus 7, but then you were like, oh, wait, no, negative 7. Why did you change it to negative?
Because I just didn't realize it was a negative 7 at first.
Right, because it's a negative 14, right? So we need to do negative 7 plus negative 7 to get negative 14. Does this look like an equation you had on your homework last night now? No? Well, that's right, because you don't know, right? So we can find our center and our radius. Daniel, what is my center? I did believe that she had done it until she made the comment earlier, so we are aware. I believed in her.
That's your first mistake.
I will always believe in you. What did you say? So that's, remember, your x coordinate, and this is your y coordinate. So your opposite. So it's negative 5, comma, positive 7. So we have a center at negative 5, comma, positive 7.
Must be recycled.
I think so. Iku, what is my radius?
9.
We take the square root of 81, which is 9. Because remember, in our formula, it's r squared. Okay, let's try that next one.
Ready?
What?
So, let's say we're trying to get is the center of the
You're just your final. Okay, your final answer is the equation. Plus, you'll be answering these two questions as well. It's all of these things. You'll have to answer all three of these things. There's like a thing that says write the equation. There's a blank that says center, and there's a blank that says radius.
Find the equation for how much
Yeah, so the equation is like your first answer, and then you can answer the other ones from there.
Sometimes I am.
All right. This one can be a little tricky. Do we have anything to move over? No. So I have x squared, and then typically I put a blank, right? Plus y squared minus 2y blank. And I heard your question, Lindsay, just one second. 35 blank blank. So Lindsay said, do I put two blanks? Why did you ask that, Lindsay?
Because there's not another x and there's not the like.
So what is our bx term then? 0. If we divide 0 by 2, we get 0. If we square 0, we still get 0. If we add 0 to both sides, we still don't do anything, right? Do we need to complete the square if there's no bx term? No. So this blank is not really necessary because our x squared is already a perfect square, right? Isn't x squared a perfect square? X times x is x squared, right? So that's why we don't have to complete that square. But we do have to complete the square for the y. So what goes in the blank of that first of the y there, Casey? What goes in the blank next to negative 2y? Negative and a negative is a? So it's a positive one. So we're really just adding 1 to both sides here. So again, x squared is already a perfect square. That's why we don't really have to complete it. 0 divided by 2 is 0. 0 squared is 0. We're really not changing anything by doing zeros. So I have x squared here plus, then we have to complete this square equals 36. Austin, how does that get completed? How does this get completed? Huh? How does this, oh, sorry, I should say how does it get factored? It's already completed. So how does this part get factored here?
plus y plus 1.
So I want to know what goes in this blank here. I don't want anything to do with x's. I've already got my x's done. These only have to do with y's. What goes in here? Y minus 1, there you go. Sorry, I probably just wasn't answering the question well. So y times y is y squared. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 1 is positive 1. Do you guys see that? So that is our equation of our circle. That is the equation of our circle. So now, did I do something?
Are you still recording?
Yeah.
She records every class.
Oh, you should go back and listen.
I don't even know that it would pick it up or not. What is our center, Devin?
It would be 0.
0, 1. And what is my radius on this one, Emma? It is 6 because the square root of 36 is 6. All right, we're going to do one more example, just one more, and then I am going to let you guys try to practice some of these problems on your own. I feel like there's just so many on here. Yeah, we'll do it that way. So this one, and then we're just going to have you guys practice. What do we need to do first on this example here?
Subtract 4.
The thing over.
Yes, you guys are doing awesome. We have to move that constant because there is a constant this time. So we're going to subtract 48. Also, you'll notice, are our x's together and our y's together? No, so I'm going to reorder that so that the x's are together. So I have x squared minus 12x blank plus y squared plus 8y blank equals negative 48. So I have 2 blanks on this side as well. So Rob. It's okay, I'll help you through. What goes in this blank here? We have to complete the square. So what's the same number plus the same number to get you to negative 12? What number can you add twice? Negative 6 and negative 6, right? So multiply to get the end term. What's negative 6 times negative 6? So we put plus 36 here. So if you do it to one side, you have to do it to the other. Kylie, what completes the square for the y?
No.
You're almost there. One more step.
16.
There you go. So after you divide by 2, you square it, so we add 16. That is like, I feel like the difference between teaching you guys this stuff and my freshmen is that they all stop at dividing by 2 and they forget to square it. Where you guys, I think, because you've done this before, even though you may not completely remember it, at least it's in the back of your head enough.
Wait, how would it,
I was here for this one.
how would it be
I was here for this part.
16 if you're squaring it? Wouldn't it be 64?
8 divided by 2 is 4. 4 squared is 16.
I never understood this last year, but now I do. Wait,
It's-
actually, I don't remember.
You see what I'm saying?
Yeah, no, I don't know why, but I thought you were supposed to square that.
No, you have to divide it by 2 first, because it's the number that you're
I'm
multiplying.
tired, Miss Maddie. I'm sorry.
You're fine. You don't have to apologize.
Like, I remember memories, but I don't remember anything.
Okay, Carmichael. What goes in this first one here?
Minus 36. Wait.
Think about what adds here and what multiplies here.
Oh, shit.
There you go. -6 plus -6 is -12. 6 times 6 is 36. Olivia, what goes in the other one, the y's? Y plus 4. So we have a center, Helena, at, and a radius, Jill, of 2. All right, I want you guys to have time to work. So I'm going to give you guys the next 20 minutes to work. And